Hi, this is Alex from devstories.eu. OpenAI Agents SDK, Episode 10 of 18. Your most powerful reasoning model is also your most expensive. If a user tries to trick it into doing their math homework or violating safety policies, you do not want to find out after it just spent 2 minutes and 1,000 tokens thinking about it. Protecting your workflows with input and output guardrails is how you prevent this. Agent-level guardrails act as bouncers for your primary models. They are separate functions, often powered by smaller, faster, and cheaper models that validate data entering or leaving your agent. By intercepting requests, they keep your expensive models focused on real work and ensure your application remains safe and on topic. You apply them in two places, at the input and at the output. Input guardrails evaluate the user's prompt before your primary agent gets to work. Consider a scenario where you have a heavy, slow model handling complex financial analysis. You can set up an input guardrail using a fast, lightweight model to review every incoming message. When a user asks a question, this fast model intercepts it. It checks if the user is trying to get the agent to do their school assignment, or perhaps attempting a prompt injection attack. If the input is flagged, the guardrail rejects it immediately and returns a standard refusal message. Your heavy reasoning model never even wakes up. You save time and you save money. Output guardrails handle the other end of the transaction. They provide a final check before the user sees the response. The main agent has completed its task, but you need to ensure no sensitive data is leaking or that the tone aligns with your company guidelines. The output guardrail reviews the generated text. If it detects a hallucination or a policy violation, it blocks the message from reaching the user. Here's the key insight. How these guardrails impact your application depends entirely on their execution mode. You can run them in blocking mode or parallel mode. Blocking mode is a strict sequence. An input guardrail must finish its evaluation and return a passing grade before the main agent is allowed to start. An output guardrail must finish checking the final response before the user receives a single word. This is the safest approach and guarantees you will not waste money on bad requests, but it adds latency to the interaction. Parallel mode trades strict cost control for speed. A common misconception is that parallel execution somehow pauses the main agent while the guardrail runs alongside it. It does not. In parallel mode, the input guardrail and the main agent start at the exact same time. The agent is actively generating text and consuming tokens while the guardrail is still evaluating the input prompt. If the guardrail decides to fail the request, it will cancel the main agent mid-flight. The user is still protected from seeing the output, but you still pay for the tokens the primary agent consumed before it was cut off. You configure this by defining a simple function that returns a pass or fail decision, attaching it to your agent and declaring its mode. Always match your execution mode to your priorities. Use blocking guardrails to protect your wallet from expensive models and parallel guardrails to protect your user experience from latency. That is all for this one. Thanks for listening and keep building.